Welcome back, everyone, to another explainer. Today, we're getting into the absolute core of Cambridge Additional Mathematics. We're specifically focusing on syllabus code 0606. But listen, if you're taking 0580, 4024, 4037, or even 4040, do not go anywhere because these principles apply straight across the board. Okay, I want you to imagine, just for a second, that you're a top-tier barrister walking into a high-stakes courtroom. The room is silent, the judge is staring at you. You can't just stand up, point at the defendant, yell, "They did it," and then sit back down, right? You'd be literally laughed out of court. You need hard evidence. You need an airtight argument. You need an undeniable logical conclusion that leaves absolutely no room for doubt. Well, tackling Cambridge mathematics is exactly the same game. But instead of a courtroom, it's your exam paper. And instead of a judge, it's a Cambridge examiner holding a red pen. Now, I see two types of students all the time. Let's call them Alex and Sam. When Alex gets a complex question, panic sets in. Alex completely overloads the page with raw mathematical facts, just dumping every single formula they know onto the paper, hoping the examiner will somehow sift through the mess and find the correct answer hidden in there somewhere. There's absolutely no analysis, it's just a desperate brain dump. When I look at papers like that, in my mind's eye, I just see red 10 marks everywhere, 0 marks for structure. Then you have Sam. Now Sam rushes. Sam sees a complex question, calculates a really quick number in their head or on the calculator, writes down x equals 4, circles it aggressively, and moves on to the next page. Sam completely misses the command word requirements. Both of these students lose massive marks. Why? Because they completely failed to build their case.
Okay, let's dive into this because a recent Cambridge Principal Examiner report stated flatly, and I'm quoting here, "Full justification of conclusions expected is one of the most misunderstood areas in additional mathematics." Now, you have to understand, Cambridge examiners are usually pretty reserved. So when they say something is the most misunderstood area, this isn't just a minor issue. This is the primary reason students are missing out on that A-star grade. The stakes are incredibly high here. When an examiner writes in their report, "Let's fix that right now," they are giving you a massive, neon-flashing hint. They're practically begging you to change your exam strategy. When you look at Alex and Sam's flawed answers side by side with the examiner's red pen marks, the problem is just glaringly obvious. Cambridge doesn't just want the final number. Any calculator can give you a number. They want to see the architecture of your thought process. They want to see the undeniable case you've built. If you just give the raw facts, or if you just give the final answer without the logical scaffolding holding it up, you get hit with a severe penalty. But don't worry, today we're going to fix exactly that, and I'm going to show you how to guarantee those method marks every single time. Here is our structural roadmap for today's explainer. We're going to methodically decode exactly what examiners are looking for. First up, we'll cover the core principles and concepts. Second, we'll break down the method mark strategy. Third, we'll introduce the critical analysis framework. And finally, we'll wrap up with the examiner's playbook, avoiding common exam traps.
Let's get right into Section 1, Core Principles and Concepts. Let's look at the theoretical foundations of what Cambridge actually expects from you.
So what is full justification? The official definition is about demonstrating connected conceptual understanding through systematic analysis and evidence-based reasoning that is transferable to unfamiliar contexts. Okay, that's a lot of academic jargon. What does that actually mean for you sitting in the exam hall? It means Cambridge wants to see mastery of fundamental principles, not just isolated mathematical facts memorized from a textbook. This is where I want to introduce you to a framework that is an absolute game changer. It's called the Peel framework. You might know Peel from writing essays in English or history: point, evidence, explanation, link. But let me tell you, it is the ultimate strategy for top students in mathematics, especially when you're dealing with extended response questions or complex proofs. Let's say you've got a question asking you to prove that a quadratic curve and a straight line never intersect. Your point is your initial algebraic setup, setting the two equations equal to each other. Your evidence is the actual calculation of the discriminant, physically writing out and solving b squared minus 4ac. Your explanation is the formal mathematical statement that the discriminant you just calculated is less than 0. And your link, this is the part everyone forgets, is your final, explicitly written sentence. Since the discriminant is less than 0, there are no real roots, justifying that the line and curve do not intersect. That right there, that is connected, evidence-based reasoning. That is a legal brief that no examiner can argue with.
Now, the assessment objectives for 0606 target these specific cognitive domains on the screen. Let's think back to our friend Alex, the one who just brain dumps formulas. Alex is firmly stuck in the first domain, knowledge and understanding. Alex knows the formula, sure, but that's it. Sam is stuck in the second domain, application. Sam can plug numbers into a calculator and get a result. But listen to me carefully. The A-star grades, the top-tier marks, they live almost entirely in the third domain, analysis. This requires candidates to move beyond rote memorization into a higher-order evaluation of complex texts and data. Imagine a student writes an answer that just says, the derivative is 2x. I put in x equals 0, the answer is 0. It's a minimum. That's application. Now compare that to a truly analytical answer. Setting the first derivative, dy over dx equals 2x, equal to 0 yields a stationary point at x equals 0. Applying the second derivative test, the second derivative equals 2, which is greater than 0, confirming the stationary point is a local minimum. Do you hear the difference? The second one follows that analytical Peel framework perfectly. It analyzes, it provides undeniable evidence, and it fully justifies the conclusion.
Moving on to Section 2, the method mark strategy. Now, what's really interesting about this slide is how it fundamentally changes how you view the marking scheme. In Cambridge mark schemes, you'll see M marks and A marks. A marks are for the final accurate answer, but those M marks, method marks, are awarded heavily for the actual process and presentation. If you master this strategy, you're scooping up points before you even finish the final calculation. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Okay, let's walk through this standardized sequence step by step. I like to call this the mathematics success blueprint. Step 1. Identify key elements. Let's do a live rewrite of Sam's rushed answer for a typical kinematics problem in our heads. Sam just sees the words find time and starts guessing. Instead, step 1 requires you to identify the elements explicitly. Is the particle at rest? That means velocity equals 0. Is it at the origin? That means displacement equals 0. You literally need to write that down. Step 2. Apply relevant principles. If you have displacement and you need velocity, you must state your principle. Differentiating displacement with respect to time gives velocity. Step 3. Execute analysis with clear working. Actually show the calculus. Don't skip steps in your head. Step 4. Verify results. Did you calculate a negative time? Well, time can't be negative in this physical context, so you must reject that root explicitly on the paper. Cross it out and write rejected. Step 5. Present in appropriate format. You have to use strict conventions here. Proper headings, correct terminology, clear annotations. If you just write a random scatter graph of numbers all over the page, the examiner can't follow your case. Professional skill development requires you to lay out your math linearly, flowing down the page with your equal signs perfectly lined up. When you transform your working to follow these 5 steps, I promise you, the red pen marks literally turn into green check marks.
All right, we are now entering Section 3, the critical analysis framework. We are shifting into the absolute highest level of assessment objectives here. This is where the magic happens. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Let's contrast these two approaches directly to show you the exact difference between an average candidate and a top scoring candidate. A standard approach gives descriptive answers. It just states what is there. The graph goes up. The value is 5. The line touches the circle. That is purely descriptive, and it won't get you top marks. A top-tier approach uses evaluative thinking. It questions assumptions, it considers perspectives, and most importantly, it justifies decisions. For example, instead of just saying, the line touches the circle, an evaluative approach says, by substituting the linear equation into the circle equation and calculating the discriminant to be exactly 0, it is justified that the line is a tangent to the circle, intersecting at exactly 1 point. It's undeniable evidence. Let's do a quick data scan challenge. Imagine a complex velocity time graph right in front of you. The line starts at 0, goes up to a sharp peak, drops straight below the x-axis, and comes back up. A descriptive student looks at that and writes, it goes up and down. An evaluative student extracts the core trend. The particle accelerates uniformly, reaches maximum positive velocity, decelerates to an instantaneous rest, and then reverses direction as indicated by the negative velocity. That is top-tier evaluation. That is how you secure the bag on exam day.
Presenting this deconstruct, solve, evaluate sequence is essentially a visual memory hack. I want you to encode these 3 problem-solving concepts into your exam strategy right now. First, deconstruct the problem. Actively highlight the command words. Does it say, show that? If it says show that, it means the final answer is already given to you, and literally 100% of the marks are in the justification. Second, solve it using systematic, logical steps. And finally, evaluate. Let's do a find the flaw challenge. Listen to this sample paragraph and find the flaw. I found the derivative. I set it to 0. X equals 3. Therefore, the maximum area is when X is 3. Did you catch it? The flaw is that the student never evaluated the reasonableness of the answer. They never proved it was a maximum rather than a minimum. They just assumed it, and they lost the final justification mark. To execute this evaluation perfectly, especially under a time crunch, use that PEL paragraph. Point: find stationary points. Evidence: first derivative equals 0 at x equals 3. Explanation: second derivative is negative at x equals 3. Link: thus it is fully justified as a maximum point. Deconstruct, solve, evaluate. That is how you win.
Section 4. Avoiding common exam traps. So the crucial point is, even if you know the math inside and out, you can still fall into the traps set by the exam format itself. Let's transition into the examiner's playbook. I'm going to rapid-fire these top 3 examiner warnings straight from the principal examiner reports, so you can use them as a final mental checklist before you walk into that exam hall. Mistake 1. Using the wrong approach for the context. This goes right back to command word decoding. If the question says hence, you must use the previous part of your answer. If you decide to be clever and use a completely different independent method, you get 0 marks. Absolutely 0. Mistake 2. Forgetting to check format and presentation. Did the question ask for exact values? Did it ask for 3 significant figures? If you write down a decimal approximation from your calculator when an exact surd was explicitly requested, your justification is completely invalid. You've answered a question they didn't ask. Mistake 3. Answers are not specific to the given context. Let's say a question is about modeling the height of a tide at a certain time using a trigonometric function. If you just give a raw math coordinate like pi over 2, 5 without relating it back to the specific time of day and actual water level in meters, you are completely ignoring the context. This ties perfectly into the time management matrix. Spend the right amount of time on the right context to guarantee those top marks.
I really need to emphasize this specific examiner alert because it comes up year after year. Candidates consistently confuse key terminology. Using and defining the correct terminology is an undeniable requirement for top marks. Please, do not use the word equation when you actually mean expression. Do not write "it crosses the line" when the mathematically correct term is "it intersects the axis." If you're explaining the nature of roots in a quadratic, clearly state the word discriminant. Don't just refer to it as the bit inside the square root. When you speak the language of mathematics accurately, you signal to the examiner that you are a top-tier candidate. You are building trust with the person marking your paper. When you use proper terminology, your argument becomes solid and you make your case absolutely undeniable.
I want to end with this provocative question. I want you to literally look back at your last study session. Look at your paper. Does your latest past paper practice show raw facts thrown onto the page in a panic, like our friend Alex? Or does it show a meticulously deconstructed, evaluated, and fully justified conclusion, just like a top barrister building an airtight legal brief? Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.